friend at home. So the instructions say, identify the open intervals on which the function is increasing or decreasing. So just the intervals, although once you have the intervals, it's a pretty easy step to who's max and who's min. But this one just says open and closed intervals. So we need to start by finding a derivative, finding critical points. You know what? Let's back up all the way. We'll just start from the beginning here. Critical points give us possible extrema. Thank you. And what we did Monday of last week and what we will do on the quiz today is find absolute extrema. What we're doing on page 183 is finding relative extrema. What did we use to find absolute extrema? Like, what was the method to get there?
Table of values.
Table of values with the critical points and the endpoints. What did we use to find relative extrema?
First derivative test.
First derivative test, so the number line thing.
That test we took Friday.
And so what this problem is asking us is to do the first derivative test, but don't make any conclusions, basically. Like, set it all up, but don't tell me extrema, just give me the intervals. So we're stopping just short of the full thing for this one. Product rule, so f prime is 1, g prime is 1/2, 16 minus x squared to the negative 1/2, chain rule, times negative 2x. So let's clean this up. That would be a negative x in the top, because the 2's would cancel. And then square root, because the 1/2, in the bottom, because the minus. 16 minus x squared. So, putting it all together. First times derivative of the second. Plus second times derivative of the first. Yeah, second times derivative of the first is just 1. And I need to know, so critical points are where f prime is 0 or f prime is undefined. I think I can pick off the undefined x's right away.
It's 4
And
negative 4.
so 4 and negative 4 would make the bottom 0. So x equals 4, x equals negative 4 are 2 of the critical points. To find the others, I'm going to have to get a common denominator. Yeah, especially today, the banging, because it's inconsistent, or I don't know, but
This is my worst nightmare.
Dude, that's so distracting.
Yeah, we should delay the quiz because it wasn't racket.
Yeah. We'll call it a noise complaint.
They have no. This is not minimal.
Yes, this is the worst thing I've ever heard.
right, like a constant noise would be better than a random.
What could they possibly be doing?
Oh, they have a rhythm.
I'm too busy trying to imagine the BPM of them banging on the wall to a random song.
X is equal to 2.
So we did the bottom already. Now we got to look at the top to figure out where it's equal to 0.
2 and negative 2.
Are you sure about that?
Sure about
Not
that.
entirely.
I mean, it could just be
I did the math.
With plus or minus. You did not do the math.
You did not do the math.
No. I said I wasn't sure, and then I did the math.
So we got all sorts of intervals on this one.
Yeah.
So negative 4, negative square root of 8, square root of 8, positive 4. So negative 5. What's a number between negative 3 and negative... Oh, I just gave away the answer.
Negative 3.
Negative 3. 0, 3, 5.
What is the square root of 8?
So, those are my test subjects. Remember my tributes to go and volunteer, and where are we going to put them? F or F prime? F prime, because F prime will tell us increasing or decreasing. So F prime. The good news is all I care about is positive and negative. So if I put in 5, I'm looking at the bottom first here, because what happens?
It does both.
It becomes a negative square root.
Yeah. So there's nothing there. So that's not increasing or decreasing. There's just nothing there.
Negative 3.
Wait, does that mean,
Go ahead. There's a couple ways we could go with this.
would that mean that positive 5 also doesn't exist?
That would mean the positive 5 is also not going to exist for the same reason.
So we can X that one out.
So if we put in negative 3,
16 minus 9 on the bottom. Or square root of 16 minus 9 on the bottom.
and in the top we'd have negative 18 plus 16
So negative 2
over positive something.
It's going down.
Yeah.
So it's negative.
Yes.
Yeah.
So F, then, if we want to make kind of a table out of this, F would be decreasing. Plug in 0,
Positive of a positive.
16 over square root of 16, positive, increasing. And if we plug in 3,
Should be negative.
negative, decreasing. So we're decreasing from negative 4 to negative square root of 8 and square root of 8 to 4. And we're increasing from negative root 8 to positive root 8. And it didn't ask, but there's a minimum right here and a maximum right there. That's just the next step that it didn't ask us for, but
With all the arrows, it feels like a crappy DDR.
So the true start point of this would be negative 4, right?
so our answer to this question is this. In the next section, it's in the next part of the homework, it asks find the min and the max, and we're almost there.
No, he was supposed to get.
So whenever you're finding this, you only use like the top of the.
But he knew what I
You said the top.
I set the top equal to 0 and the bottom equal to 0. So the bottom gave me, alright, listen. The bottom gave me is where f prime is undefined. So that was 4 and negative 4. Where the top is equal to 0, that would be plus and minus square root of 8. So this is a good one because it had everything in it. Usually you don't have to worry about all of it, but this one you did.
What time were we starting?
10 minutes.
No, you do both.
See, I thought, yeah.
You do both.
So number 37. That's a good question because of the piecewise thing here. So this says find the critical numbers, open intervals where it's increasing and decreasing, and then find relative extrema. So f prime, we need to separate. We'll have a piecewise f prime as well. So it's negative 2x when x is less than or equal to 0, and negative 2 when x is greater than 0. So I want to know where f prime is 0 or undefined. So it's equal to 0. The only place it's equal to 0 is at 0. Now, I need to be super careful at 0 because there could be a cusp. So I need to be very careful at 0. So I would want to check x equals 0, but it already showed up as a spot where the derivative is 0. So there might be a cusp there because we're changing functions. The good news is I already have 0 down. So 0 is my only critical point. Basically, any breakpoint is a critical point because you could have an undefined, you could have a cusp there, which would make the derivative undefined, which makes it a critical point.
But is it?
So let's try negative 1 and 1, plugging them into f prime. Now I've got to be super careful here. When
Negative 1 has to go to...
When x is negative 1, I'm using this formula. So that means f is increasing.
And, well...
If I plug in 1,
You,
I got to use the other one.
well, you can't plug in 1.
I can't plug it in, so the answer is just negative 2, which means that f is decreasing.
At the same rate, so everything's okay.
So I have, or wait, what did it ask me for? So it's increasing from negative infinity to 0. It's decreasing from 0 to infinity. And what's happening at 0?
There's probably some sort of cusp.
It might be a cusp, but what is it in terms of max or min?
Math.
There's a max at x equals 0 because we have to say something about f prime. F prime
Changes from
positive to negative. Again, max, relative max, f prime changes positive to negative. Those are almost always tied together.